Okay, so let's continue on looking at the derivative. So where we were last time was we were looking at kind of like thinking about how we should think about the derivative. So we start off with the derivative being the instantaneous rate of speed, a rate of change. So it's kind of like a speed, a velocity, like how fast is something changing. We can also think of it as a slope. So if we graph our function, it'll be the slope of the function. We can also interpret it as kind of like some sort of marginal thing. So if we measuring cost, the derivative will be the marginal cost. So we can think of that as what will one extra unit of input, how much output would it give us? So to say there's a derivative of 3, that's where units come into important. So if we talk about 3 feet per second, that means in a second we gain an extra 3 feet. Okay. We can also think of it as as a multiplier. So it turns change in input into change in output. So to say the derivative is 3, and if we change by 2 in the input, that means the output's going to change by 6. So these are all different ways of thinking about derivative, and it's all the same way. Okay, so an important thing we've realized is that the derivative is a function itself. So we start off with a function. Remember what a function is? It's just a way of turning inputs into outputs. The next thing we realize is the derivative itself is a function. Okay, so what it is, if I give you x, then what you do is you figure out what is the instantaneous rate of change of f at x. And that's just a function, right? You give it inputs, you can figure out the outputs. So if it is a function, you can take its derivative. And we get what's called the second derivative. And usually we call it f double prime of x. Or in the Leibniz notation, we call it that. So we put the 2 here and here. So the reason why we put the 2 here is, again, we think of it as a kind of an operator. It sort of acts on things. It comes along, you give it y, and it gives you the second derivative of y. Okay, and so that's what I want to talk about today. So the first thing we've got to realize is, what information does it tell us? Well, let's go back and think about, what does the derivative say about the function? So we've got f and f prime. So if f is increasing, f prime is positive. And if it's decreasing, it's negative. And if it's flat, it's 0. Okay, so the information it gives us is that if f prime is increasing or decreasing or flat, remember what flat means? It means like constant. Then f double prime is positive, negative, or 0. let's go back. What does f prime increasing mean for f? So if we've got a function, what does f prime increasing looks like? It means it's getting steeper and steeper. So it means it looks something like this, or it's something like this. What do we call those kinds of functions? Concave up. What happens if f prime is decreasing? Then it looks like something like, starts off steep, looks something like that. What's that, Peyton?
Concave down.
Concave down. Okay, and here's the harder one. What happens if f prime is constant? What does that mean? Well, if f prime is constant, that means the slope isn't changing. What does it mean if the slope isn't changing? It's linear. And remember, linear is something which is neither concave up or concave down. It's the change. So that would look something like this. We maybe start off with something which is concave up, going to concave down. So at some point in the middle there, it's looking like a straight line. There's no curvature, and that's where the second derivative is 0. So we see that the second derivative actually gives us useful information. And you can talk about third derivatives and fourth derivatives and that, but they usually don't give you much information about how things look. So usually just doing the first derivative and the second derivative give you heaps of information about a function and tell you what you need to know. Okay. So graphically, let's do a few things. Let's get rid of this. So here is a function. Okay, so what can you tell me about its derivative? Just a sign, negative or positive. That's all I'm interested in.
Negative and then positive.
Yeah, here it's negative and here it's positive. So if I do a little f prime, here it's negative, here it's positive, and here it's 0. Whereas f, the value f itself, right, it's positive here, and it's 0 there. What about the second derivative?
It's all positive.
It's all positive, right, because it starts off really steep and all the time it's increasing. So it's positive everywhere.
What would the graph of that look like?
So actually, if this was a parabola, right? So Eric, is it? Eric's right. If this was f prime would kind of look like this. So f double prime would look like this. Of course, but this might be, if it's a parabola. There's other kind of U shapes like that that are not parabolas. We'll see them later. So the parabola is the simplest U shape. So this is simplest U shape. You see it's got the simplest derivative that a U shape can have, and it's got the simplest second derivative that a U shape can have. They can be more complicated. Okay, let's do another one. So this one here, what can you tell me about the first derivative?
Positive.
Positive. And why is that?
It's increasing.
It's an increasing function. What can you tell me about the second derivative?